Welcome to our overview of 5th grade structure and properties of matter. In this unit, students are investigating whether new substances can be created by combining other substances by focusing on 3 ideas. 1. Students will describe that matter is made of particles too small to be seen through the development of a model. 2. They will develop an understanding of the idea that regardless of the type of change that matter undergoes, the total weight of matter is conserved. 3. They will determine whether the mixing of 2 or more substances results in a new substance based upon observations of properties. Coming into this unit, students may think everything that exists is matter, including light, heat, and electricity, or may believe that matter does not include a liquid or a gas, and that liquid and gases are weightless materials. Although students may start seeing weight as a fundamental property of all matter, many students think of weight simply as felt weight. Something whose weight they cannot feel is considered to have no weight at all. For example, if I keep dividing a piece of styrofoam, I soon would attain a piece that weighed nothing at all. In looking at the lesson sequence, we first see that students are introduced to the idea that matter of any type can be subdivided into particles that are too small to be seen. In Lesson 1, Clay Cutting, students are provided an experience to discover this on their own, as they are asked to divide a block of clay in half as many times as possible. With this activity, have students share their sample of clay with their classmates. Who made the smallest piece? Would it be possible to make this piece any smaller? Is this still clay? How do you know? With this activity, it's important for students to understand that the clay still exists and can be detected by other means even if cut into pieces too small to be seen through the use of a microscope or a magnifying glass. In science, models can be diagrams, physical replicas, mathematical representations, analogies, or computer simulations, and are used to represent a system or an idea under study to aid in the development of a question and explanations, to generate data that can be used to make predictions, and to communicate ideas to others. Models are based upon evidence, and when new evidence is uncovered that the model cannot explain any longer, models are modified. During Lesson 2, the basketball demo, students create a model showing what has caused the basketball to inflate, building upon Lesson 1, that matter is made of particles too small to be seen. For the purpose of Lesson 2, the model is recommended to be a labeled diagram with a written description of what caused the basketball to inflate. The model should include what the students believe is inside the basketball, what it looks like inside the basketball, and the evidence to support that claim. Have students share their model with the class, and ask students to defend what has been included within their model. Some questions to consider are, I see these dots in your model. Can you tell me what these represent? I see you included arrows. What was their purpose? I see you included numbers. Why? In Lessons 3 through 6, the focus is on the idea that the amount of matter is conserved when it changes form, even when it seems to vanish, as observed in Lesson 4 when the sugar is dissolved in water. This reinforces the idea that matter is made of particles too small to be seen. In this sequence of activities, there are open-ended questions that are based upon the cross-cutting concepts. As we look at this sequence of lessons, the idea of a system is referring to the actual experiment that the students completed. As in Lesson 3, that would include the vinegar, steel wool, cup, plastic wrap, and thermometer. Questions specific to scale are asking students to think about whether the same result would be observed with significant changes in the amount of the given materials. For example, a swimming pool worth of vinegar and a Volkswagen-sized piece of steel wool. In Lessons 7 through 13, students are investigating a variety of properties. Hardness, reflectivity, just as an example. They can be used to identify particular materials. While Lesson 13 contains a PowerPoint and worksheet and appears to be a vocabulary-driven lesson, It was designed to promote student discussion of the various properties, giving students an opportunity to cite potential examples that they have observed of these properties. A possible way to facilitate this activity is through providing students the answer key and asking them to identify examples and non-examples. For example, ductility. It's the ability to bend without breaking. Potential example being a piece of wire, and a non-example being uncooked spaghetti. In lessons 14 and 15, we're focused on having students conduct an investigation on whether the mixing of two substances results in a new substance. These two lessons are designed to be open-ended and engage students to think and act as scientists as they plan an investigation and hypothesize about possible outcomes based upon their prior experiences with early lessons. This is a great opportunity for students to see the relationship and connections between all the standards within this unit. As a facilitator, it's important to discuss what makes an effective investigation. Is this experiment repeatable by others? What data will be collected? What's the experiment's purpose? What conclusions can be made from this experiment? As you are planning the activities for this unit, please be sure that you have all necessary materials to support the tasks. Inventory lists are posted on SharePoint, and please feel free to contact us with any questions, to request support, or to share any ideas that you've developed as a team. Thank you.